I'm so confused. What does all this RFID lingo mean? I am your presenter, Joe Crable, and I am a mobile solutions architect here at PTS. So what we want to cover today is some of the different lingo that's out there. So some of you may be reviewing spec sheets to antennas or tags or readers, and you see all this jargon, you know, what's LF or HF versus UHF, you know, what is EPC, what is a user bank, you know, what is DB, what is GPIO. So there's a lot of terminology out there when it comes to RFID. So understanding all of that will help you make a better decision on what type of hardware and software you want to ultimately go with for your RFID install. So some of the things I want to cover today are the types of RFID, what is passive versus active RFID, the operating frequencies of RFID. As you'll see, this will vary per region, your power level or sensitivity, so basically the power that you would set on your reader. Also, we have the different components to an RFID system, which all starts with the RFID tag. So we'll dive a little bit into tags and tag memory and what some of the terminology means. We'll dive a little bit into RFID readers, fixed versus mobile, and some of the settings that are available for that. We'll also talk about RFID antennas, so how some of those settings can impact read distance and strength. And then we'll finish it up with, this is really for fixed RFID only, but the type of cables out there and the connection types, as some people do get confused based on the reader and the antenna they choose requires a different type of cable connection. So before we get started with the presentation, if you do have any questions at any point during the webinar, please type them into the question panel, and we can address those at the conclusion of the webinar. If we're unable to address your questions today, you can always email us at the contact info below. All right, so I want to start off with the components of an RFID system. So we have 4 components here. At a very high level, you have your RFID tag, which is the label or tag that gets applied to the item you're tracking. And it's what's read by the reader antenna or antenna to actually transmit some form of data back to a destination. So RFID tags do come in various shapes and sizes, and some are specifically meant to be applied to a certain surface or material and actually will read better on a particular surface, such as a non-metal tag. You won't see the read range or performance in clean air versus if you actually had it mounted on something metal. The next component would be sort of the brains of the operation, your RFID reader. So that's the device used to read the information from the RFID tag using radio waves, and then transmits that data back to the destination software. The RFID antenna, which is typically connected to a reader, is the device that's used to power up the RFID tag to transmit that data and send it back to the reader. In a mobile system, the reader and antenna are typically the same. They're kind of all built into the same enclosure. As you'll notice by those that are familiar with the mobile readers, you'll see sort of that cone or radar looking component on the front of the device. In a fixed solution, typically you will need to add additional antennas to it. And this is good, and then it enables the users to choose from a wide variety of antennas based on their specific needs. As you'll see, that antennas come in all shapes and flavors as well, depending on the type of performance that you need and the environment that you're in. The last component would be the actual RFID software, which is able to actually take that data you're reading with the RFID system and then put that into something that makes sense to you, such as a back-end database, or if you're just reviewing it on a mobile device, it will display on the screen for you and you can actually capture and perform some form of logic or functionality on that data as it's read. So our software, such as Tracer Plus, which is for mobile RFID, and Clearstream, which is for fixed RFID, is able to read that data and transmit it directly to a back-end database or system. So I also want to talk about the types of RFID out there. The first being low frequency, or LF. So that ranges in a frequency of 30 kilohertz to 300 kilohertz, but typically operates between 125 or 134 kilohertz. Low frequency provides a short read range. It is slow with reading, and it's not very sensitive to radio wave interference, which is good that you shouldn't have to worry too much about environmental factors. Common applications for low frequency are access control or animal tracking. So those are some of the common apps for that. The next one is high frequency, or HF, which ranges from 3 megahertz to 30 megahertz. But you'll typically see that operate at a 13.56 megahertz. This also has a short read range, but it does have moderate sensitivity to interference. Similar to low frequency, this is a close range solution. Common apps including, some ticketing, payment, and some access control type settings. I would say at least the most common in our field is the ultra high frequency, or UHF. So that ranges between 300 megahertz and 3 gigahertz, but you'll see it typically operate between the 860 and 960 megahertz band. So with UHF, you're going to get long read ranges as well as much faster data transfer rates. However, it is more sensitive to interference from metals, liquids, any other type of electromagnetic signals. But new designs and innovations are actually helping some of those issues. So some of the readers, antennas, and tags are kind of starting to combat some of that interference. Common uses for this include inventory, asset tracking. If you see RFID portals, that's typically a UHF install. And that's also very useful in check-in, check-out type applications where you're passing things in and out of a room or a doorway and you want to know whether something's in or out. So that's where UHF is very useful. And UHF is also supported by our Tracer Plus and Clearstream software. The last thing I want to talk about is NFC, or near field communication, which is a form of HF, or high frequency. So you'll see this on most of your smartphones or tablets and some of the rugged Android mobile computers and tablets that are out there. Its use cases are for mobile payments, which I use myself, as well as, you can communicate from the device to device. So there's some printers out there that are NFC enabled where you can just now tap your phone or device to the printer and it'll print out for you. That's using NFC technology. NFC is also supported by our Tracer Plus software. All right, now we'll talk a little bit about passive versus active RFID, which you may hear a lot. Passive RFID systems are the most common. As in the word passive, they don't use any internal power source. So the tags are not battery powered, it's just a straight tag. So you'll see that it's definitely the cheaper solution. The tag is powered by the energy transmitted from the RFID reader and antennas. Common uses are for access control, file tracking, race timing, supply chain management, smart labels, and much more. Pretty much use it for anything, and based on what you're mounting the tag to, you can choose specific tags for that application. Like I said, it is a lower price point, so it makes employing a passive RFID system much more economical for many industries, and like I said, it is used the most compared to active. Passive is what is supported by Tracer Plus and Clearstream. So active RFID systems use battery-powered RFID tags that continuously broadcast the signal. They're commonly used as beacons to accurately track the real-time location of assets, or in high-speed environments such as tolling. So those of you that are familiar with EasyPass, that is typically an active RFID system. They do provide a much longer read range than passive tags, but they're also much more expensive. So you don't see too many of those deployed just due to the pricing. Next, we'll move on to the operational frequency, or the frequency range. So I'm really just going to talk about UHF because that's kind of what we're diving into, and that's what our software mostly supports. So UHF ranges from, actually it's 860 to 960 megahertz, but we commonly see it between the 865 to 928 band. All RFID readers, antennas, and tags have their own operating frequency range. So you'll see in the US, the supported range is between 902 and 928 megahertz. In the EU, it's 865 to 868, and then global is the full 860 to 960 band. So you'll also find that readers, antennas, and tags can support all regions, or it can be region specific. So based on the type of hardware you're buying, you may see that you need to purchase it for region specific, like you have to purchase a fixed reader for US or a fixed reader for EU, whereas the mobile reader can sometimes support both regions, and then you set the region at the software level. All right, so one of the main factors here of choosing an RFID system is the power level. So this is going to determine what power you're outputting from the reader and determining how well that performs based on the antennas you're using or the tags. So for a mobile RFID system, the power level is set in the software loaded to the device. So in this case, if you're using our Tracer Plus software, you can set the power level you want that to read at. So it's defined in dBs and is typically a set range supported by that particular reader. The higher the level you set, the further the read distance and the narrower the cone. So picture a cone coming out from the front of the device. As you dial that power up further, that cone sort of narrows and it's more focused, allowing you to get a longer read range. The lower you set this level to, the shorter the distance you're going to get, but the larger the cone. So picture if you're up close reading tags, but they're kind of spread out. You may pick them up better if you dial back the power, as you'll get a larger cone. So for fixed RFID, the power level is set at the reader, and then it's transmit to the antennas through a cable. So depending on the type of cable you choose, which we'll cover a little bit later, you can actually lose signal based on the thickness or the distance that cable is run. So power level can be affected by that. There's also different settings within antennas that determine how that power level is received and then transmitted out to the tags. So we'll talk a little bit about antenna settings and how those kind of affect power level. Once again, like mobile, it's defined in the fixed RFID software, and the difference here is that you're actually defining a power level for each antenna that you connect to the reader. So most readers will support anywhere from 2 to 8 antennas, and with our ClearStream software, you're able to set a power level for each one of those antennas individually. So based on where they're located, you may want to dial up or dial back the power level, depending on how you want to read the tags. Once again, it is defined in dB, and it's typically a set range based on the type of reader that you're connecting to. And once again, the higher the level, the further the distance, and the more focused the cone, the shorter the distance, the lower the level, the shorter the distance, but the larger the cone. So you want to do a lot of testing when it comes to power level. So we find that if you set it too high, you may get the distance you want. However, you may end up getting stray reads from an adjacent room or some other tags that may be laying around that can kind of affect the accuracy of your reads. So this is definitely one thing you want to test very thoroughly to make sure that you're not picking up reads that you don't want to, but that you're still able to pick up the tags that you do want to and at the distance that you want to. Distance will also depend on the type of tag you're using and what it's mounted to. So there's definitely a lot of factors here that can affect the power level, also including any type of interference, whether that be electromagnetic, liquid, metal. So all of these can have effect on power level. So that's definitely things to consider when actually testing. So that's definitely why we put it as one of the first components, as it's definitely very important in determining how you read everything. Next, I want to talk about the RFID tag and its components. So an RFID tag is made up of an IC, or an integrated circuit, which is the chip and the antenna in the tag. Different chips or ICs determine what can be written to the tag, how much data can actually be written to it, and the performance of the tag. Tag size is defined in bits. So you'll typically see on a RFID tag spec sheet that the different memory banks will be defined by a certain size, and it's typically in bits. So each memory bank is defined in bits, and there are 8 bits in a single byte. And that determines how many characters can actually be encoded to the tag's memory banks. So if we talk a little bit about the tag memory, there's 4 components or memory banks to an RFID tag. You have your EPC, or electronic product code, which is used in most applications to identify the item. This should be unique for every tag. Size-wise, it's typically between 96 and 128 bits, and it is your first writable bank. The next bank is the user, which is used to store additional information about the item tagged that wouldn't normally fit on the EPC. Typically no more than 512 bits in size. However, there are some higher memory tags out there that can support 4K or 8 kilobytes. This is your second writable bank, and some tags, depending on the IC, do not support or offer this additional memory. Sometimes that can be to increase performance, as you'll find that tags without user memory may get a further read range. The next bank is the TID, or the tag ID, and it's the number assigned by the manufacturer when the IC is actually made. Typically, this memory portion cannot be changed or written to. We don't find that many people need to actually read the tag ID, but we do give you the option in our Tracer Plus and ClearStream software that once the EPC is read, you can actually read that tag ID. The last bank is called the reserved bank, and it's what stores the kill and access passwords, and are each 32 bits. So the kill password permanently disables the tag. It's not used very often, but if you actually wanted to kill a tag, you could write a password to it and then issue a kill command. The access password is set to lock and unlock the tag's write capabilities. So if you want to lock the tag from being rewritten out in the field, you could use an access password when encoding the tag. But we haven't seen much of that used as well. So those are the components of your tag. Next, we'll talk about read range, which you'll see on some spec sheets. So read range should be taken with a grain of salt. It is a theoretical read range you can expect from the tag based on a set power level and environment. If it's not stated otherwise, these values are typically for fixed readers, which provide more power. So you typically tend to see longer read ranges with a fixed reader versus a mobile reader. Some spec sheets will define fixed versus mobile read ranges. But like I said, these are theoretical. It's typically done at a set power level in a perfect environment, which most of us don't have. So this is definitely another factor to consider when doing your testing. You should test this thoroughly, as everybody's environment is different. Depending on what you're mounting them on, you want to choose the correct tag. So if it's a metal item or an asset, you may want to choose a non-metal type tag. If you're tracking chemicals or liquids, you want a tag specific for liquids, such as like a flag tag that kind of flaps out from the bottle itself, so it's not mounted on the liquid. So there's definitely lots of different tags there. So that's definitely something to consider based on what you're mounting on, and do perform a lot of testing with that. Also, one last thing when it comes to tags is how the tags are actually encoded. So you may have sometimes heard the terms hex versus ASCII or hexadecimal versus text. So tags can actually be encoded with hexadecimal data or ASCII data. So your hexadecimal data is your typical hex data 0 through 9, A through F. And that's what's typically encoded to a tag if you buy it from a manufacturer. It's what we typically recommend you encode the tag with if you're doing your own printing or encoding. So it's meant to be read in what we call hex mode by the reader. Each byte can fit 2 hex characters, so a common 96-bit EPC can be encoded with a length of 24 hex characters. If a tag is encoded in hex, you cannot read this in ASCII mode. So those of you, we actually do hear this a lot. Some people set their readers to ASCII mode and then they complain to us that the tags they're reading are just showing sort of garbage characters. This is because you're reading a hex tag, or a tag that was encoded in hex, but you're reading in ASCII mode. So that's why you have to be in hex mode for a hex tag. Tags can also be encoded in ASCII or text format, but should only be used when you need the EPC to represent a human readable value, such as maybe an asset tag or a serial number. If you do want to encode tags using that, ASCII mode is probably the best solution, as you have full support of the ASCII character set. So each byte can fit a single ASCII character, so your common 96-bit EPC will fit up to 12 ASCII characters. So ASCII tags can actually be read in hex mode, but they will be read as their hex representation. So for example, if you encoded a tag in ASCII with a value of 1, that would actually be read in hex mode as 31. That is the hex representation of the ASCII character 1. So that's the basics of hex versus ASCII and why you may want to use one versus the other. Next, we're going to jump into reader components. So as I was talking about before, region. So when you're looking at a reader spec sheet, you may see the region that's supported. So fixed readers are typically region specific. So you do have to purchase a reader specific to your region, and it's typically a different part number. Mobile readers typically will actually support all regions, but you have to define the region in the device's RFID settings, such as the what we see with Zebra's MC9190Z. It does support a wider frequency. However, you can actually go into the RFID settings and define its region. So in our case, we would define it for US, which I think is region 15. So some of the aspects of mobile RFID are output power. So when you're looking at this, you may see it measured in watts. So typically 1 or 2 watts. So 1 watt equals 30 dBs of power. So that typically means your reader can output up to 30 decibels when you set your power level. It can also sometimes give a field, which is measured in degrees, and it's the cone that's measured from the nose of the device. So picture the angle of the cone that would emit from that nose of the device. Read range, once again, that is theoretical and something you can expect. Once again, it's going to be based on the tag you use, what it's applied to, in the environment it is in. Fixed RFID, once again, power output. They typically measure it in dB, and it's the range of the power output that can be set. Read range isn't really defined for fixed readers because that's going to be solely dependent on the antenna that you're connecting to it. So it can only determine the power output that you can supply to the antennas. Another thing you'll see with fixed RFID readers is the GPIO, or the general purpose input-output. So these are used to trigger a reader to turn on or sound off lights and buzzers. So you have your inputs, or your GPI. So these are typically used to turn on a reader, such as a motion sensor or a light sensor. So this is typically useful if you don't want to run the reader constantly, and you just want to turn it on when somebody comes into the room or walks past a certain point. You can use a motion sensor that will then send a signal to the input, and then using the RFID software such as Clearstream, you can then tell that RFID reader to turn on, and typically you tell it to run for a certain amount of time. So maybe you'll run it for 30 seconds to allow that person to fully walk through the gateway. Your output, or your GPO, is typically going to be used to power on lights and buzzers as RFID tags are read. Once again, using something like our Clearstream software, you can actually turn on a light when a tag is read or when data is updating in the database. You can also sound alarms or buzzers if something passes that shouldn't be allowed. So some of that functionality is built into Clearstream to actually send a signal to that GPO port, which will then turn on whatever is connected to it. Depending on the reader, you may need an external power supply to power up these inputs and outputs. For example, the FX7500 from Zebra does have a built-in 24-volt power supply that you can use for these inputs and outputs, whereas their 9500, you would have to supply your own 24-volt power supply to power up those readers or those outputs. And the last thing I want to talk about when it comes to reader components is the read mode that I was referring to before when I was discussing tags. So you have your hex versus ASCII, or hexadecimal and text. So when you're reading hexadecimal tags, you should make sure that your reader is set to hex mode so that it reads those properly and what you're expecting to actually receive. If your tags are encoded in ASCII, you want to make sure that that software is set to read in ASCII mode. So both Tracer Plus and Clearstream support this mode. So if your tags were encoded in ASCII, make sure you set that. And it'll read those in the text format. All right, so the next thing I want to talk about is antenna components. So this is for fixed RFID only, but it's what gets a lot of people tripped up in some of the terminology that's mentioned. So if you've ever looked at an antenna spec sheet, you may see things like polarization, gain, beam width, among other things. There are some other things like VSWR, front-to-back ratio, axial ratio, but I'm not really going to talk about those. I just want to talk about sort of the key factors in choosing your antenna and what you should be looking for. So the first thing is the polarization of the antenna. So you have circular versus linear. So with a circular polarization, picture the RFID wave coming out of the antenna in two planes, basically creating a circular effect like a corkscrew. So you'll kind of see that this enables you to cover any tag that's in its path eventually because of its rotational field, so it's constantly moving in a circle. So RFID tag orientation isn't really a concern, and it's not something that really needs to be known. One thing to note with circular polarization is you do lose typically 3 dBs when compared to a linear polarized antenna, but that's typically compensated for an antenna dB gain. So circular polarization is good for environments where you need a long read range. However, don't know how your tags are going to be oriented or how they're going to be placed on an item. And that's typically the more common setup we see. Linear polarization is picture a wave that just propagates entirely in one plane, vertical or horizontal in the direction of the signal. So this is the best option when you know the tag orientation and you know that it's always going to be fixed in this certain position. The antenna and tag should also be matched in polarization to obtain the best read rates. So you'll find that this is a more focused wave. You can sometimes get a further read range with linear as long as that tag is always in a fixed position. All right, so the next thing you'll see is the gain or dB gain, sometimes referred to. So to get technical, it's the ratio of the power required at the input of a loss-free reference antenna to the power supplied to the input of the given antenna to produce in a given direction the same field strength at the same distance. So basically, antenna gain, it's expressed in decibels. The higher the gain, the more powerful the energy output, or typically the better read range and performance you will get. Antennas, antennas with higher gain will be able to read tags from farther away. Obviously, antennas with a lower gain won't be able to read as far, but actually may be able to read things more spread out, as the cone will be sort of wider, which we'll talk about in the beam width below. A 3 dB gain on an antenna is equal to an increase of 2 times the signal strength, whereas a 3 dB loss typically means you're cutting about 50% of the signal strength. So that also applies to power level. So as you increase power level on a reader, 3 dBs, you will be increasing that by double. You'll basically be doubling the power. For every dB, you increase that reader power. Or excuse me, every 3 dBs, you increase that reader level. All right, and then the last thing I want to talk about with antennas is the beam width. So commonly referred to as a 3 dB beam width. It is measured in degrees, and it's the angle of the radiation pattern that's typically measured both horizontally and vertically, because you'll have a beam or a cone that emits from the antenna horizontally, but also vertically from the top and bottom. So beam width is typically determined by the gain. The higher the gain, the more focused the beam will be to achieve further read ranges, so sort of the narrower the cone. The lower the gain, the wider the beam, resulting in shorter read ranges, but you'll also be able to capture things, that are in a closer range, but maybe spread out further. So tinkering with that power level also affects this gain. So as you see here, beam can also be controlled by reader power level. So the higher the power, the more focus it's going to be. The lower the power, the shorter, but the more wider it's going to be. So you'll be able to capture things maybe a little bit wider in comparison to the antenna if it's at close range. All right, so the next thing I want to talk about is the cable and the connector types. So this is for fixed RFID only. So connecting of a reader to an antenna requires a coaxial cable with matching ends for your reader and antenna. So the first thing to consider is cable thickness. So cables do come in different thicknesses, and depending on the length of run and the amount of signal loss, this is definitely an important factor. So LMR 195 is your thinnest cable and recommended for runs under 25 feet. And it's also the most flexible cable, so it's easier to fit around tight curves and corners and bends a lot easier. The next up, or the mid-range, is the LMR 240, which is probably the more common use, as it gives you, you can run it longer, up to 50 feet with minimal loss, but it also maintains some flexibility for most installs, so you can still run that, in tight corners. Your LMR 400 is your thickest, sometimes described as thick as a dime. And it's the least flexible cable, but is an extremely low loss and high performance cable. This is recommended for runs over 50 feet, and you shouldn't even experience much loss at 100 feet or above. So depending on where your reader is located compared to your antennas, you're going to want to choose the appropriate cable type to get the best performance. Obviously, the thicker the cable, the more costly it gets, but it's typically not that much of a difference. Now, based on the manufacturer of the reader or the antenna, they use different connectors on each end. So it's important to know these before purchasing a cable. And some of the common connections are listed below. You have your SMA male/female. So your SMA female connectors are commonly found on RFID antennas such as ×7. You'll see mostly SMA, but you can also see it on antenna hubs such as the Impinj antenna hub has the SMA female connectors, and then some readers such as FIG also have SMA female connectors as their antenna ports. So for these connectors, you want to make sure to use an SMA male connector for your cable and make sure that's installed on one end of the cable. All right, so the next cable type we see is the N male or female. So N female connectors are commonly found on RFID antennas. Most zebra antennas use the N female connector. And when you use a cable, you want to make sure you have a N male connector on one end of your cable to connect these. Lastly, we want to talk about the RP TNC male or female. commonly referred to as RTNC or reverse polarity TNC. So RPTNC female connectors are typically found on most fixed RFID readers as their antenna ports. So Impinj, Zebra, Alien, these typically all have the RPTNC female connector as their antenna port on the reader itself. So you want to make sure that the end of your cable has an RPTNC male connector as your cable connection. So some of the standard cables that are typically offered are RPTNC male to N male, RPTNC male to SMA male, or in the event of a FIG reader with a ×7 antenna, you would have an SMA male to SMA male cable. You'll also find extenders out there, which would be an RPTNC male to RPTNC female. This would allow you to extend an existing cable that you may have. And just to kind of show you what some of the connectors look like, I put a slide together with the images. You'll see this is an N male, what an N female looks like, the SMA male versus the SMA female. You have your TNC male versus TNC female, which we don't often use. It's really the RPTNC male and female. So you'll see it's a female, but it actually has the pin in the middle. Whereas the RPTNC male is a male connector, but has the insert for that pin. And lastly, I just want to finish up by talking a little bit about the software solutions we offer for RFID. So for Tracer Plus, we have our, for mobile RFID, we have our Tracer Plus software, which you can actually go to www.tracerplus.com to learn more. So we support natively Zebra devices, so your MC3190Z, your 9190Z, your RFD 5500 sled, and also support for the RFD 8500 sled, which can be used with Android and iOS devices as a Bluetooth option to actually add RFID functionality to a device that doesn't have RFID. So Tracer Plus is a mobile development tool that allows you to create apps pretty much in minutes, and you can also view our online solution of apps. Pre-configured apps that you can use as is or modify to your liking. So we suggest you tune into one of our Tracer Plus webinars. We typically do a Getting Started webinar if you want to learn more about Tracer Plus and how it may fit into your organization. Then we have our fixed RFID solution called Clearstream RFID, and you can learn more at www.clearstreamrfid.com. And that is also a tool that enables you to quickly connect to an RFID reader, add its antennas, and then send that data back to the database of your choice. We support readers from Zebra, Impinj, FIG, Alien, ThingMagic, Intermec, or pretty much any reader that runs the LLRP protocol. So there's a lot of control over that, and we even offer a virtual site survey or an emulator where you can actually create a virtual RFID environment and kind of test how fixed RFID works or how you can kind of lay out your own solution. So we also do have webinars on this, and we just recently released version 4.1. And I think we actually have a webinar upcoming either this Thursday or next week, so you may want to tune into that to learn more about our Clearstream RFID fixed solution. So that's pretty much what I wanted to cover today, kind of clear up some of the terms that are out there when you're viewing information on RFID hardware and software, and things to consider when testing. Testing. We always recommend doing very thorough testing when it comes to RFID, as there are so many factors involved But with that being said, I will now answer some questions. We do have some questions here. Questions on if you can use a mobile RFID reader as a tag locator with both a passive and active tag. I'm not sure how that would work for an active tag, being that it's sort of a beacon. I think an active tag you would probably just be able to locate and know where it is, whereas a passive tag you can use what we call the Geiger counter or tag locator in our Tracer Plus software to actually try and locate an item. So as you get closer to an item, it will beep more frequently, and you'll also see a meter on the screen that pulses a little bit more frequently as well. So you can use that with Tracer Plus to actually locate or home in on an item with a tag that you have selected. Question here, if you can write a hyperlink in a tag, the mobile fixed reader would then use the Wi-Fi or data plan to access the file via the hyperlink. If so, how easy is it? And are there limitations, i.e. attaching item manifest in a container? So that may be something you can do. It wouldn't be something supported with our Tracer Plus software, although you could, in essence, if the hyperlink is not too long, you could write that or encode that to a user bank, and then when you read the EPC, that can parse out that hyperlink, and then you would have that in a field of data, but then what you do with that hyperlink would probably have to be done via third party. Maybe once you sync the data back to a database, maybe then your database looks at that hyperlink and then goes to that link and attaches whatever it needs to. So that may be a way you could use that solution. All right, we have another question here. In a warehouse with bin locations on racks that are 30+ feet high and have multiple unique lot numbers in one bin, how well does RFID work for scanning tags to select one lot number out of many from that different distance? Well, I guess that would depend on the type of tag that's used as well as what's reading it. Also, whether you're using a fixed versus a mobile solution. So if you're using a mobile, I imagine you would just point that up at the bin, but keep in mind that you could essentially read other tags in the area. So it may be something that you would track as you're taking an item out of a bin versus trying to read it from the bin 30 feet up. Another question here, on what applications have you seen RFID that we should be talking about to our customers? So we seem to be doing a lot more RFID applications lately. From the mobile side, it's more of a sort of asset tracking or an inventory perspective where they're loading a list of items to a device. Then they select a location, scan all the assets in a location, and then they basically can report on what was missing versus what was found and use further things such as a Geiger counter to try and locate something that's missing. So that's one of our very common mobile apps right now. You can also do a check-in, check-out type application with mobile. We're also seeing that a lot. From the fixed side, I would say that check-in, check-out is a big one right now. So keeping track of items that come into or leave a specific area, such as a tool crib or maybe a supply closet or an IT type closet where they want to check in or out PCs or tools. So that's a good solution. You basically put an antenna inside and outside the door. If it passes one way, we know that it's checked in. If it passes the other way, we know that it's checked out. And then we just update that in the database with its current status so we know where it is. Other options for that are to actually put antennas on shelves to track maybe inventory on a shelf. So you can kind of see as things are removed and added to a shelf. So that's something we're seeing a lot of. Obviously, you can scale that to something larger than a shelf. But yeah, a lot of gateway or ingress, egress type scenarios for RFID, or just knowing where it is throughout a building, positioning antennas in different spots. So as it passes, you know where that item is. All right, well, looks like we don't have any more questions. If you do happen to have any questions at any point after the webinar, please feel free to reach out to us with the info below. You can even follow us on YouTube, or check us out on YouTube and see some of our videos. We do a lot of tutorial videos and review videos or general topic reviews. Follow us on Facebook and Twitter, and check us out on LinkedIn. But I want to thank everyone for attending today, and I hope you enjoy the rest of your day.